Hi students, welcome to the chapter of coordinate geometry. Coordinate geometry is all about plotting of points on a graph sheet. It is a Cartesian plane having an x-axis and y-axis. The x-axis is the horizontal axis and y-axis is the vertical axis. The intersection of x-axis and y-axis is called the point of origin, where the x-coordinate is 0 and the y-coordinate is also 0. Now, Cartesian plane is used, the graph sheet is used for mapping two-dimensional objects such as floor plan of a house or street plan of a locality. It has a wide range of uses, and the distance between the plotted points on 2 points on a graph could be found by a formula. Now, the Cartesian plane itself is divided into four sections. On the top right is the first quadrant, where x-axis and y-axis will have both positive signs. That is, x-coordinate is also positive, y-coordinate is also positive. Quadrant 2 on the top left side is x-axis having a minus sign and y-axis is having a positive sign. Therefore, x-coordinate is minus sign, y-coordinate is plus sign. And the third quadrant to the bottom left is all having negative signs, both x-coordinate and y-coordinate, because that section is concerned about minus x-axis and minus y-axis. And the fourth quadrant to the bottom right, x will have positive sign and y will have minus sign. This is in respect of the quadrants of the Cartesian plane. Now, how the distance is found out between 2 points on a line segment. Let us see the formula here. The distance between a line segment points A and B, where point A is represented as x1, y1 coordinate, point B is represented as x2, y2 coordinate. The distance formula will be square root of x2 minus x1 whole squared plus y2 minus y1 whole squared, or x1 minus x square root of x1 minus x2 whole squared plus y1 minus y2 whole squared, whichever way you can remember. The midpoint of the line segment is found by the formula x1 plus x2 coordinate divided by 2, y1 plus y2 coordinate divided by 2. Now, the centroid of an equilateral triangle which has three vertex A, B and C with coordinates x1, y1, x2, y2, x3, y3. The centroid of a triangle is found by x1 plus x2 plus x3 divided by 3, and then y1 plus y2 plus y3 divided by 3. All are coordinates. Now, the line segment could be divided in some ratio. Left hand side will be divided in the ratio of 2, right hand side will be divided in the ratio of 1. So, in a line segment A and B, there could be some point C either closer to B or closer to A, depending upon the ratio of division. So, the coordinate of point C is found by the formula where m is the ratio, m is to n is the ratio in which the line segment is divided by point C. The coordinates of C is equal to mx2 plus nx1 divided by m plus n, my2 plus ny1 divided by m plus n, where m and n are the ratios in which the line segment is divided, and x1, x2, y1, y2 are coordinates. Therefore, the line segment could be divided either internally or externally. We shall see all these in these problems. Between x and y coordinate, x coordinate is called the abscissa and the y coordinate is called the ordinate. The distance between 2 points A and B, as shown in the slide, is found by the formula square root of x2 minus x1 whole squared plus y2 minus y1 whole squared, or square root of x1 minus x2 whole squared plus y1 minus y2 whole squared. Here point A is 6, 4, that is x1, y1. B is 7, minus 2, that is x2, y2. Therefore, AB is equal to 7 minus 6 whole squared plus minus 2 minus 4 whole squared, which takes you to 1 squared plus minus 6 squared, that is root 37. If you try the other way around, 6 minus 7 whole squared plus 4 minus of minus 2 whole squared, the same result, root 37, will come. So if C is the midpoint, then between 6, 4 and 7 minus 2, x plus 1 plus x plus 2 by 2 and y1 plus y2 plus 2 by 2 will be the answer. That is, if A is 6, 4, B is 7 minus 2, then x coordinate will be x1 plus x2 by 2 and y coordinate of the midpoint will be y1 plus y2 by 2. That gives you 13 by 2, 1. The coordinates of the centroid of a triangle is given by the formula x1 plus x2 plus x3 by 3, y1 plus y2 plus y3 by 3. Centroid is a point C in the figure. It is the point where all the three medians intersect. Median is the one which connects each vertex to the midpoint of its opposite side. Let A be x1, y1, B be x2, y2, C be x3, y3. Then the centroid coordinate is x1 plus x2 plus x3 by 3, y1 plus y2 plus y3 by 3. The section formula is used to find when a point divides line segment AB in two ratios. If P is a point on the line segment which divides it internally or externally, the section formula is used. The section formula is mx2 plus nx1 by m plus n, my2 plus ny1 by m plus n, where m is to n is the ratio in which the line segment is divided. It could be either internal division or external division. Now, internal division problem, let us see in this slide. 7, minus 6 is A, 3, 4 is B, that is x1, y1 is 7 minus 6, x2, y2 is 3, 4. Then applying mx2 plus nx1 by m plus n, my2 plus ny1 by m plus n, where the line segment AB is divided in the ratio of 2:3, where section AB is equal to 2, PAB is equal to 3. Then you get the result as 27 by 5, minus 2. Let us see some more problems on internal division and external division. In problem 2, the line segment AB is divided by C in the ratio of 5:4, where A coordinate is minus 5, 7 and B coordinate is 3 minus 5, and point C divides AB in the ratio of AC is 5, CB is 4. Then point C coordinate x and y is given by mx2 plus nx1 by m plus n, my2 plus ny1 by m plus n, which gives you minus 5 by 9 and 1 by 3. The next problem is about the external division to the left. So here C divides line AB externally. So AC is m and BC is n. So it is dividing it in the ratio of m is to n or m1 is to m2 in the ratio of 7 is to 3. Then the point P is given by xy. Point P xy coordinate is equal to m1 x2 minus m2 x1 by m1 minus m2, m1 y2 minus m2 y1 by m1 minus 1 m2. That gives you 2 and 2. Next formula, P divides line segment AB externally in the ratio of AC by BC is equal to 11 by 6, which is equal to m1 by m2, external division to the right. Point C divides line segment AB externally in the ratio of AC being 11, BC being 6. Then applying for point C external division x1 y coordinate or m1x2 minus m2x1 by m1 minus m2, m1y2 minus m2y1 by m1 minus m2. That solving this and substituting the coordinates x2, x1, y1, y2, you get 24, 2. In the problem now shown by the slide, ABC is a triangle where DEF are its midpoints. D is 5, 1, E coordinate is 6, 5, F coordinate is 0, 3 respectively. Find A, B, C coordinates of vertices A, B and C. Now D, E, F are midpoints. Use midpoint formula. Midpoint formula D, x1 plus x2 by 2 is equal to 5, which is equal to x1 plus x2 is 10. Then similarly y1 plus y2 by 2 is equal to 1, y1 plus y2 is equal to 2. Then coming down to BC, x2 plus x3 by 2 is equal to 6, and y2 plus y3 by 2 is equal to 5, y2 plus y3 is equal to 10. Then going to line segment CA, x1 plus x3 by 2 is equal to 0, and y1 plus y3 by 2 is equal to 3. That is y1 plus y3 is equal to 6. From equation 1 and 3, we get it solved to x2 minus x3 is equal to 10 and y2 minus y3 is equal to minus 4. Both are equation 4. Now equation 4 and equation 2 taken together and adding them, you get x2 is 11 and y2 is equal to 3. Then x1 plus x2 is equal to 10 in equation 1, where you find x1 is equal to minus 1, y1 is equal to minus 1. Then x2 plus x3 is 12, and substituting the value of 11 x2 and y2 3, you get x3 is equal to 1, y3 is equal to 7. Therefore, x1 is minus 1, y1 is minus 1, x2 is 11, y2 is 3, x3 is 1, y3 is 7. Coming to the next problem, P, Q, R are the points that divide the line segment AB in 4 equal parts. You have to find the coordinates of P, Q and R. Now AB is a line segment and AP is equal to PQ is equal to QR is equal to RB. Point A has the coordinate minus 2, 2, which is represented by x1, y1. Point B is having coordinates 2, 8, represented by x2, y2. Now, applying the formula mx2 plus nx1 by m plus n, my2 plus ny1 by m plus n, which divides the line segment in 2 ratios. Now take for the time being AP is equal to 1 and PB is equal to 3. That is PQ plus QR plus RB. So PXY is equal to 1 into 2 plus 3 into minus 2 by 1 plus 3, 1 into 8 plus 3 into 2 by 1 plus 3. That takes us to minus 1, 7 by 2. Now coming to the next point Q, which is the midpoint of AB. AQ is equal to QB. So you can take this AP plus PQ is 2, it is in the ratio of 2:2 or 1:1. So applying the same formula, mx2 plus nx1 by m plus n, my2 plus ny1 by m plus n, you get 0 and 5. Now coming back to the point R, AR has got 3 AP ratio 3, that is AP plus PQ plus QR is 3 parts together is ratio 3 and RB is 1, 3:1. So apply the formula again, mx2 plus nx1 by m plus n, my2 plus ny1 by m plus n, then you get 1, 13 by 2. Look at the slide to find the ratio in which the point P between line segment AB divides line segment AB in some ratio. Now find the ratio in which line segment joining the points A indicated by coordinates minus 3, 10 and B 6, minus 8 is divided by P point minus 1, 6. So let us assume that AP is to PB is in the ratio of K is to 1. Let AP be K and PB be 1. Now, point P coordinate minus 1, 6 is indicated by the formula mx2 plus nx1 by m plus n, comma my2 plus ny1 by m plus n, where m is equal to k, where n is equal to 1. So the denominator is k plus 1. So the coordinates, substituting the coordinates and the ratio value, you get 6k minus 3 by k plus 1, comma 10 minus k by k plus 1 is equal to point P within bracket minus 1 and 6. Therefore, 6k minus 3 by k plus 1 is equated to coordinate x minus 1, which gives us 6k minus 3 is equal to minus k minus 1. Therefore, k by 1 is equal to 2 by 7. Then on the right hand side, if you get 10 minus 8k by k plus 1 is equal to 6. Solving that, you get k by 1 is equal to 2 by 7. Therefore, P divides AB in the ratio of 2:7. Now, see this problem in which P divides line segment AB in the ratio of AP to PB in the ratio of 1:2. And Q divides line segment AB in the ratio of AQ is to QB, which is equal to 2:1. You have to find the coordinates of P and Q and the value of the intersecting lines, that is K. Now, A is minus 3 minus 2 and B is 12, 10. So, A is x1, y1, B is x2, y2. To find the coordinate P, x3, y3, we have this formula m1 x2 plus m2 x1 by m plus n, m1 y2 plus m2 y1 by m plus n. Using this formula, we get P coordinate x3, y3 as 2, 2. Now, point Q x4, y4 coordinate is found by this formula again, m1 x2 plus m2 x1 by m plus n, m1 y2 plus m2 y1 by m plus n. Here the ratio of division is 2:1, but denominator 2 plus 1 is 3, as is the case in the previous point. Now, x4, y4 we get as 7, 6. If you plot A, B, P, Q on a graph sheet also, you can demonstrate that P divides AB in the ratio 1:2 and Q divides AB in the ratio 2:1. You can also prove that these points are collinear, lie on the same line, by finding their distances, that is AB, PB and AP with the distance formula, where AP plus PB is equal to AB. Similarly, AQ plus QB is equal to AB. You can find these with the distance formula. Between intersecting line 2x plus 4y minus k 0 at the point P 2 and 2, substitute the value of x and y in this equation and you will get k as plus 12. Similarly, for intersecting line 4x minus 8y plus k at Q, if you substitute the value of x and y as 7 and 6, you will get k the value as plus 20. Thank you.